was setting up a SparkFun SAMD21 Dev board as a USB host through the onboard USB port while simultaneously using a serial port as a console monitor. In order to connect to the additional serial port, I connected a FT232R USB to serial port adapter. When making this connection, either a stray charge or an imbalance in ground references between the host computer, the interconnected dev and COM boards, or an external power supply caused the interface chip on the COM board and the processor chip on the dev board to be destroyed. I was able to repair the COM board by replacing the onboard chip. This video will cover replacing the processor chip on the SparkFun Dev board and reflashing the USB bootloader firmware on the chip. I am using a solder rework station with the appropriate TQFP nozzle. A large diameter circular nozzle would also work for this type of package due to its small size. I usually set the temperature of the soldering station to 240 degrees. The next step is to clean and remove excess solder from the processor pads on the board. This can be done using solder wick and a soldering iron. Lay the solder wick on the board and place the soldering iron on the solder wick. When the solder wick starts to emit smoke, draw the soldering iron along the wick above the terminals to be cleaned. Don't overdo this part. It is possible to raise the pads from the board if they are heated too much. In order to replace the new chip, we're going to use solder paste that comes in a tube like this, and we're going to use some solder flux which comes in this tube. Place a thin bead of the solder paste on the clean board pins. The best way to do this is using a syringe type dispenser with a fine tip to lay a small diameter trail of solder on the pins on each side of the package. Try to lay a line with the smallest amount of solder possible. Don't worry about solder getting between the pins, as surface tension and flux will draw excess solder onto the metal pads and pins. Now remove the chip from the carrier tape. Pick the chip up with a pair of tweezers. Note that there is an indented area in the top of the chip. This indicates the chip alignment. When the chip is placed on the board, this indented area should be aligned on the corner of the component pad that is marked with a small white dot. Try to align the pins both horizontally and vertically as well as possible, and avoid having the chip rotated within the frame of the board pins. Now carefully dispense a small bead of solder flux around the chip outside of the area where the solder was placed. Once again, try to use the smallest possible amount. The flux will help the solder to adhere to the pins and aid in drawing the chip into the correct alignment. Soldering will be performed by using the solder rework tool. Start heating the tool up to 230 degrees Celsius. Once the tool has heated, hold it over the part vertically about 3/4 of an inch away from the board surface. After a while, the solder flux will melt and flow, and eventually the solder will liquefy. It should flow onto the pins of the part and the board traces. Continue to heat the board until all the solder has melted. Some solder may remain between and bridging some pins. This solder will be removed later with solder wick. Once all the solder has liquefied, remove the tool from the board. Let the solder cool and harden. Now examine the pins on each side of the part for solder bridges. These can be removed with solder wick and a soldering iron. Place the wick on the pins that are bridged. Place the soldering iron on the solder wick. Wait until a small amount of smoke rises from the joint. This should be enough to pull the excess solder up into the solder wick braid. Remove the iron and wick before the solder cools. When doing this operation, try to avoid placing any sideward pressure on the pins, as this may bend them and cause short circuits. What the hell is going on out there? Verify that there are no remaining solder bridges by holding the board up to a bright light and observing that light can be seen between each pair of pins on the part. Use a loupe or magnifying glass. A new SAMD21 chip from the manufacturer does not contain a pre-installed USB bootloader. The only programming capability provided by the manufacturer is through an SWD or single-wire debugging port that is enabled when power, clock, and reset are applied to the chip. In order to use this port, an external programmer needs to be connected to the appropriate chip pins. On the SparkFun Dev board, these connections are brought out to a 10-pin header on the board. To program the bootloader onto the chip, CMSIS DAP interface is needed. CMSIS DAP is a standardized protocol to access the Core Site Debug Access Port, or DAP, on ARM Cortex microcontrollers, of which the SAMD21 is a member. After looking around on the net, I found one on Adafruit that was listed at $30. What I didn't grasp at the time was that this adapter was no longer supported by the manufacturer. I did find some information on how to reflash the adapter to get it to work with OpenOCD and the SAMD21. The link to the article is in the description below. Note that this procedure is oriented toward Mac OS and I wanted to use Windows. A link to an additional video showing how to set up this board to use with Windows is included below. To begin the replacement, software for the adapter was obtained from the Mbed website. The parts of the Adafruit kit consist of the programmer itself, a adapter board that can go from the smaller ribbon type connector to a 20-pin standard JTAG type connector, and a short ribbon cable. In order to connect the JTAG SWD programmer to the breakout board, it's necessary to populate the 10-pin connector. The pin pattern is for a 2x5 0.05-inch center male header to connect to the cable supplied with the programmer. I purchased a header to populate this connector along with the programmer. The headers are readily available though on DigiKey and other sources for this particular format. This header was designed for surface mounting, so I had to straighten the pins to fit the through-hole connector pattern. Okay, now I'm going to install the connector into the board. Do a little solder here. Make sure you check the orientation of the connector too, and make sure it lines up with the orientation on the board. It's difficult to have to remove it if you don't get the orientation correct. There we go. Now we're ready for the programming. The dev board will be powered through the programmer cable. Remove any other power connections from the USB connector, the battery connector, or the coaxial DC connector if it is installed. Connect the SWD programmer to the host computer with the mini USB-C cable. The computer should detect the programmer and display a message "Installing device DAP link." If that doesn't occur, press the reset button. Connect the SWD programmer to the header installed previously using the ribbon cable. Use the TGT_DBG connector. The red power LED on the dev board should light. In order to start the programming process, OpenOCD has to be started, and it runs on Windows 10 as a server application, listening on a couple of ports for instructions. First of all, I went to the location where OpenOCD exe file is located, and that's right here. And I also included at this location the binary file for the SparkFun SAMD21 Dev board. That's this file. In order to start the OpenOCD, which runs as a server application on Windows 10, you need to enter the following command. Once that's entered, then by running the command, it will start the server, open the command port, and then open the detect the programmer and open it, and make sure that there's a board connected to the, or a detectable processor connected to the programmer. And you can see that it's we'll be using the telnet port on 4444 to enter commands, but it does detect a processor, and it's indicated that right on this line right here. So once that's running, then you can start entering programming commands. That's done through a telnet session. Okay. Add a command prompt. You can start the telnet session on port 4444. And on the OpenOCD prompt should show up, indicating that the application is ready to accept commands. If you enter poll, it'll indicate that there's a processor present. Now the next command is a program command, and you type in the name of the file that you want to program. And then hitting enter, it'll run the programmer. And as you can see, it successfully programmed the chip. And then by typing in reset, it'll reset the chip and start running the bootloader program. Now in order to exit the programming process, you can hit shutdown or shutdown. And that stops the connection to the programming interface. To test the bootloader installation, disconnect the programmer from the dev board. Now connect the dev board to the host computer directly through the USB-C connector. You will probably get a message installing SparkFun Dev Board on COM10 or some other port number. The power LED should light. The board is now ready to use, and you can open the Arduino IDE and select the board from the board manager. Open the Arduino IDE and select the board from the board manager. Check that the COM port shows the correct mapping. Then select the blink sketch from the example sketches on the SparkFun SAMD21 Dev Board page. Copy the code and paste it into the Arduino IDE sketch template. Save the sketch to the sketchbook in case you want to use it again. Now compile and upload the sketch. After the IDE successfully compiles and uploads the program to the dev board, the processor will be reset and the program will start to execute. Here the blink program flashes the 3 LEDs in succession. This indicates that the bootloader correctly uploaded the program and the processor is running it correctly. The damage repair is a success. If you found this video helpful, please hit the like button. For more content about electronic synthesizers, microcontrollers, and using computers in music production, please hit the subscribe button and punch the notify icon to be informed when new content has been added. Thanks for watching.